Okay, so we are saying we need to understand more concept, and we've just said the mole is the amount of substance that contains as many entities or as many particles as there are in exactly 12 grams of carbon 12 isotope. And we have said one mole of anything, okay, one mole of anything is always going to be 6.022 times 10 to the power 23. It can be atoms, particles, molecules, or ions. Okay. For example, if we say one mole of glucose has got 6.02 times 10 to the power 23 ions, or particles, or molecules. One mole of carbon dioxide has got the same number, 6.02 times 10 to the power 23 atoms. One mole of, let's say, aluminium is also going to contain the same number. So as long as we are talking about one mole, it always has the same number of particles or molecules. So how do you calculate number of moles? Number of moles is given by mass divided by the molar mass. For example, when you want to find the number of moles of oxygen gas, the first thing you need to know is what the formula for oxygen gas is. Now you know that oxygen should always exist with a 2 down there because it's a diatomic gas. So for example, fluorine always exists as a 2 with a 2, nitrogen, hydrogen, oxygen, chlorine, all these are put here, they always exist with a 2. Phosphorus, you'll just find it like this. Okay, you'll find neon just like this, but they are gases, but these, they always exist as diatomic gases. So you need to know that. So we want to find the number. Let's say they're given as 2 grams of oxygen, and we want to find the number of moles. First thing we need to determine is the molar mass. We have got 2 oxygens here times, if you check on the periodic table, something that will always be given, the molar mass is 16. So 2 times 16, it will give you 32. This is called molar. Molar means 1 mole. So it is gram per mole, meaning that you have got 2 grams in 1 mole. Okay, so to find the number of moles, you're going to say mass, which is 2 grams, divided by the molar mass, which is 32 grams per mole, like that. So if we get to divide 2 divided by 32, that is going to give us about 0.0625. So this gram and this gram will cancel, are going to remain with a mole. So this is going to be the answer. It doesn't matter the kind of question that you've been given. The only thing that you need to know is the molar mass. Okay, you need to know the molar mass. If you know the molar mass, you also do need to know what? You need to also know the mass to find the number of moles. At times you can be given the number of particles. Okay, so you can also determine number of moles if you've been given number of particles. Number of moles is given by X over Na. So this Na we are saying is Avogadro's constant. For example, they've given you 2.6 times 10 to the power 23 particles. They ask you to find the number of moles. Okay, you are going to divide this value by the Avogadro's number, because you know what? You know that 1 mole of something is equal to 6.022 times 10 to the power 23 particles. Okay, now you've been given 2.6 times 10 to the power 23 particles. You want to find out how many moles are in that compound. That's what you want to find out. So you're going to cross multiply and divide, and the formula will give you this one. So number of moles is given by number of particles divided by Avogadro's number. That's another formula. Okay, if I want, I'll just say x times this one, and then 1 times this one, and then to remain with x, I'll divide both sides by this value, which is here. Now, another important thing to understand when you're talking about number of moles is to understand it when you have concentration. So we also need to know what concentration is. It's a very, very important concept, concentration. So what is concentration? Mark, what is concentration?
Okay, suppression is the number of mass, the amount of a substance.
Okay, so concentration is the moles of solute per volume of solution. That's what we define as concentration. Moles of solute per volume of solution. So therefore the formula is going to become concentration with a C is given as moles, number of moles over volume. So this is the formula just from the definition, moles of solute per volume of solution. That gives us concentration. Now because then the unit for moles is a mole, okay? And then the unit for volume that you're supposed to use here is a liter. But 1 liter is the same as 1 decimeter cubed. This one you need to know. 1 liter is the same as 1 decimeter cubed. Therefore, you can say concentration is going to be more per liter because we've got a liter down. Volume is going to be in liters. So more per liter or more per decimeter cubed because the decimeter cubed and the liter is the same thing. So that is the unit for concentration. Now we are saying moles of solute per volume of solution. What do we mean? Well, so we have got solute here. We also have a solution, but for you to form a solution, you have a solute. You need also to have a solvent, and then you are going to have a solution. Okay, like that. So a solute is anything dissolved, anything that is dissolved is called a solute. A solvent is anything you dissolve into. Okay, that's what we call a solvent. And then a solution is a mixture. When you get to mix a solution, I mean a solute and a solvent, you are going to form what we call a solution. For example, I'm going to get water. We have got water here. Okay, this water we can dissolve something into that, so it is going to be called a solvent because we are able to dissolve things in the water. And then let's say I get sugar, I put in the water, the sugar. So the sugar here is going to be known as a solute because it is something that can dissolve if I add it or if I put it in water. So when we mix now these, we are going to form, okay, if you mix the sugar into the water, you will not see the sugar because the sugar dissolves. Okay, the sugar dissolves. So because the sugar dissolves, we say sugar is soluble in water. It is soluble. Why? Because it is able to dissolve. So we are going to form a solution there. Okay, that is the thing. So I've got now a solution. So to calculate the concentration, need the number of moles and you need the volume. Okay, let's say for example, you've been given,
Yes.
okay, let's look at an example of calculating concentration. Let me just get something that I'm able to use from the periodic table. All right. So let's say we've been given uh, sodium chloride. Sodium chloride, this is table salt, the salt that we use. So let's say they've said given, let's say 40 grams of sodium chloride dissolved in 20 liters of water. Calculate the concentration. So this is a question that comes in your exam. Now you want to calculate the concentration. So remember, the first thing that you need to find before get to calculate the concentration is the what? Number of moles. So I'm going to say number of moles. What are you dealing with here is sodium chloride. So I'll just put sodium chloride down here. So number of moles of sodium chloride, please just write this small, not big. So number of moles of sodium chloride is given by mass over molar mass. Okay, like that. So the mass of sodium chloride that you've been given is 40 grams. Now, what's the molar mass of sodium chloride? You need now to go on the periodic table. On the periodic table, the molar mass for chlorine is 35.5. The molar mass for sodium is 23. If you check on the periodic table, so we're going to add these. Okay, let's do that. So 23 plus 35.5, we are going to get 58.5. This is the molar mass. It is in grams per mole. So we're going to say mass over molar mass, which is 58.5 grams per mole. So if we divide this gram, we'll cancel with this gram. So let's do that. 40 divided by 58.5, that is going to give us 0.684 moles. Now that we've determined the number of moles, we are now going to say concentration is equal to number of moles over volume. We now know the number of moles, which is 0.684 moles divided by volume. The volume is what? We've been given in 20 liters of water, so 20 liters. So we need now to divide 0.684 divided by 20. So this is going to give us 0.0342. You see on top we have got a mole, down we have got a liter. So the unit is going to be mole per liter. That is going to be the unit. Now, in this case, we are going to say one type of concentration. This concentration that we are using here, this type of concentration, which is known as number of moles over volume, is called molarity. Okay, so if they ask you to calculate the molarity, they've just asked you to calculate the concentration. It's the same thing. Okay, so the symbol for molarity is capital M. So we can also say capital M, which is molarity, is given as the number of moles over volume. So this answer that we've given here, because it is molarity, we can also say 0.0342. We are going to put a capital M. That's the unit for molarity, molar. Okay, molar. So what are we saying? We are saying that 1 molar is the same as 1 mole per liter. This is the meaning. Since we are saying where there is mole per liter, we can also use what? We can also use molar. So it's the same thing. Okay, so this is how we are able to calculate concentration, and this is the formula for concentration.